Okay, so now we're recording. So welcome everybody to our second class. So this is the more complicated agenda where we want to start out with a half hour of reviewing the sketching, the basic subjects. And then I'll do a little demo on top-down design and parameters. So going over, I'll do the bookcase again that we did last week, only do it in a different way. And then the second hour can be more of a happy hour, show and tell. And Mark has agreed to demo how to use the tool to generate the G code for the Prusa 3D printer. So on that note, does anybody have specific questions about sketching, about what's been said about sketching, anything still unresolved from last week, or stuff that you've picked up and what you've been looking through?
I'm sorry, is this the SketchUp meeting?
No, no, sketching, not SketchUp.
Cut him off. Cut him off, will you?
Bye, Pete.
We said this was the beginner class, not the remedial class.
He's a Zoom bomber.
Okay, okay, Tim. We've properly kicked this off now.
Well, unfortunately for those people who have a lot of experience on SketchUp, I don't, so I can't make any parallels there. But you know, Autodesk does have the SketchUp to Fusion 360 transition training and the SolidWorks to Fusion 360 transition training. But I'm not good with either of those, so I can't really give much guidance along that direction. So if everyone is fairly comfortable with the concept of sketching, I just want to reiterate verbally that a couple of key concepts. One is your drawing doesn't have to be fully constrained. In an engineering sense, it typically is, and there's a lot of times when you do a simple sketch, there's constraints you can get away without using. As you start to do more top-down and parametric, you'll see sometimes where that'll come back and bite you a little bit. Fortunately, it's easy to fix, but I'm going to go through a demo in a little bit where I do the bookcase from a top-down approach with parameters, and we see what happens with some of those assumptions in the early sketching as we move along and as we do what we call flexing the model, which is testing it with different parameters to see that it behaves as expected. The couple of key points when we talk about dimensioning and constraining a sketch is we want as much as possible to include our design intent. So we dimension the way we would explain or the way we would think about cutting apart or building apart. What's the functional need for dimensioning and constraining. So rather than just constraining to make sure it gets there and we have dimensions, it should be dimensions that make sense from the...
Excuse me, Autodesk Fusion 360 app needs your attention.
Whoops.
Who was that?
Somebody's system is talking. I'm not sure it was, I don't think it was mine. Sounds like an accessibility tool. Or okay Google talking back to somebody. Anyways, so the purpose or the philosophy of how to dimension and constrain a sketch is down to the philosophy of what the part is really about and what those dimensions mean to you. And then the other point I want to make is that there's a lot of cases in which you can do complicated features and have few features, or you can do some simpler features and have more of them. And I'm going to just run through right now a real quick little demo where I make the pencil box that our friend on Learn 360 or Die Trying does. But I'm going to just take a different approach to how to build that so that everyone can kind of see, hey, there's a different way to do it, and there might be some logic behind it. And in my case, I'm going to use more features, but I think it's simpler, it's easier to edit, etc. And I'm going to do this not with parameters in this case. I'm just going to do a bottom-up approach to the pencil case. So I'm going to start out. I have an untitled project. So one of the things we should do typically is save it. And I'm going to say pencil box for a name. And then the first thing I want to do is create my new component, which is going to be the base. And the parent is the top assembly, which is correct. I want to activate it. Yes. And here we go. So I'm going to sketch starting on the XY plane. And I'm going to make a rectangle from the origin. And I'm not really paying a whole lot of attention to what the actual dimensions are. Well, actually, you know what? I think I have my grid turned off. My snap to grid turned off. I'll do this. So it's snap to grid. I'm going to add a couple of simple dimensions. And finish my sketch. Then back to my default view. I'm going to extrude this sketch upwards, and let's make it about 200. And then I'm going to fit the zoom. So there's my beginnings of the pencil case. Now you remember that the other guy, when he did it, he put fillets in his sketch. And I often don't. What I'll do instead is I'll add the fillet as a solid feature. So I'm kind of used to doing it that way, and I find it easier, like I say, to manage features when I break them down a little bit. So there's some fillets. I'm going to say, okay, now this is a solid box that's part of the case. And maybe my height isn't really a good one, but that's irrelevant at this point. So now I'm going to create another sketch on this top surface, and I'm going to use an offset from the outside, and let's bring this in, I don't know, minus say 2 millimeters, and finish the sketch. And now I'm going to extrude this profile. And I'm going to take it down. And you notice when I take it down, the operation automatically changes to cut. So I've done that. Now I have the solid block with the overlap available. And one of my favorite tools, because particularly for doing plastics, is a shell. So I'll grab this, and let's say we go with, I don't know, 3 millimeters. And now, if you want to see what that looks like, let's do a section analysis from this side in. And you can see that I've got the step for the lip. Now, if you're doing this on let's say we're going to do this on the Prusa, on a 3D printer. Well, I don't like this ledge here, because the Prusa is going to need to support that. So what I'm going to do is I'm going to modify and use a chamfer. And I'm going to grab this tangent chain. So notice tangent chain is highlighted here. I'm using an equal distance chamfer. I could use a 2 distances chamfer if I wanted to. Grab this here, And see, how is this? Did I get the right one? Come on. This is giving me 2. Let's go with 3. There's the chamfer I want. I'm going to say OK. Now this can build all the way up.
Hey,
Just
Tim,
like that, I've got the base built.
Tim,
Yeah.
maybe I'm in the camp of some other people on this meeting. I watched 3 of the 5 videos thinking I maybe didn't need to watch the other 2. You did 2 things that I didn't anticipate. One was using the shell to hollow it out. Was that in the videos?
No.
Okay, so maybe you could touch on that because that was a distinctly cool but unexpected thing you did. And the other thing was you did this cross-sectional view,
Yep.
which I am not familiar with, and you just zipped right into it. I'd be curious how you did that.
Okay, great. Thanks for the questions. And that's exactly what I want you guys to do. So I'm going to back up to before the shell. So I'll leave the cross section in for now, but I'll explain it a little bit different, a little bit later. But so this was a solid body that I created. Now, often when you design plastics for injection molding, for example, and there's a lot of other cases as well, you want a fairly consistent wall thickness. So you can create an object like this that you can have all kinds of complication in it, and then at the appropriate time, you want to effectively hollow it out. So the way the shell feature works, let me just advance. There it's done, but let's edit it so we can look at the definition. You select faces to be removed because you don't want just a hole in the middle, and you specify the thickness of the shell. So, you can define a part as a series of surfaces and then add thickness, or you can design a part as a solid and then shell it out. Either way, you can get a specified wall thickness in a fairly complex shape with multiple surfaces involved. It's a very, very useful tool. You can put in complex, tapers, all kinds of fillets, etc., and then shell it out at the appropriate time.
And which surface did you use to then say 3mm offset, and how did you keep it from going through to the base?
So basically what it did here is all the surfaces except the surface I selected is a surface to be removed entirely, right?
Okay.
So let me do this one again. Let me actually go to the end. Let me just delete a couple of these features and step through it. Okay, so I've got a solid object, and maybe I'll hide the section. So I've got a solid object here, and I want a consistent wall thickness. Now, any surface, when I hit shell, any surface I select is effectively going to be removed. So in this case, it was only this one. But if I wanted to, for example, I could, if I added this one, now both of these surfaces will be removed. And the thickness can come inside, or the thickness can go outside. If I go outside like this, I can grow a thickness.
Okay. So thickness is just another version of offset here.
Effectively, yeah, but it's offset of the solid the surface of the solid. Now in this case, remember I picked the bottom this time. So if you look, you'll see that the bottom is also removed.
And the reason the bottom was not removed previously is because you said 3mm all the way around. And so even the base was 3mm.
Correct.
Okay, good. Thank you.
Because I was making a container, right?
And Tim, I've got a question for you also,
Sure.
Dallas. So you start with a solid, so it's completely enclosed. All sides are enclosed to do this. Is that correct?
That was correct.
Okay, thank you.
Yeah. So it's not a, there's a lot of other, I'm not sure about SketchUp. I think maybe there's a number of simpler CAD programs that are really surface modelers. And you define the surface of everything, and the solid is whatever happens to be inside. In Fusion 360, we can define surfaces, and which have no mass. They're infinitesimally thin, but you can do a lot of things with surfaces. Once you have a complex surface, if you want to, you can add a thickness to that surface, and as long as it's mathematically sound, it'll give you a thickness, and now you have something you can work with. Another approach is to take the solids modeling approach, develop a solid, and in this case, do a shell. So that was one feature that was new to you. So it's kind of something I wanted to spring on you and show you. Now, the other thing that I showed you was the section analysis. And it's really useful just to see what's going on and make sure that you're getting the results you want. Under the Inspect pull-down menu, there's a number of different kinds of analyses, and we'll eventually hit some more of these. But the most useful one, the simplest one, is the section analysis. And what this does, this gives you sort of a dynamic section capability, and you can grab a flat space somewhere and then move it in dynamically to see what the cross section is at that spot. So 10 millimeters in, we're in that whole side wall, so it's all solid.
Tim,
20 millimeters in, we're just starting to see a bit.
the surface you choose defines the plane.
Correct. So the plane will move parallel to the surface you choose. It's a little weird picking a surface of the model itself. In my history, I would have always used a plane. Maybe made a datum plane or used some kind of a plane to do that with, because I kind of prefer that being almost separate. But it's a helpful tool to look at what's going on inside a part when you have geometry like this. And when you have a whole complex assembly, you can take a cross section through the whole assembly, make sure things are properly aligned the way they should be. Are the screws going in the hole? Are the, is the geometry internal to your part or assembly what you really were expecting it to be?
Tim, just for my mental checklist, this is the first time we've ever done anything within the Inspect menu, correct?
Yes.
Okay,
That's
thanks.
correct. Yeah.
Tim, this is Dallas again. I've got another question. You mentioned when you were doing that chamfer, that tangent thing. What is that about?
Tangent.
The connected tangents.
Oh,
I think he meant the chained.
The chained ones.
Oh, yeah. Okay, yeah. So basically, what that was saying is, let me go back to the modify chamfer, and so tangent chain. So if tangent chain is not selected, if I pick an edge, I'm only going to get the edge I actually pick. Now, if I include tangent chain, then escape this. If I include a tangent chain, then the edge that I pick, let me pick this one here. The edge that I pick to chamfer, so the selection set will continue as long as the edge has a tangent feature to it.
Got
If
it.
it comes to a sharp corner, it won't.
Got it.
Right?
So it does not include like perpendiculars?
Correct.
It's just tangents to a line. Okay, good.
Correct. Yeah. So, for example, if we didn't have the fillets in here, even with tangent chain, it would only take this up to the corner, one line up to the corner. So the concept of tangent chains is very useful. There's a lot of times you use it. It's similar with the round. So let's take, or a fillet, I mean, sorry. Fillet will do the same thing. And, oops, that's not very much of a fillet, is it? I guess in this scale here, we need 2 millimeters. And there's our fillet. And it's gone all the way around. As long as it's a contiguous tangent chain of edges, that they will all be selected.
Okay, I have a question about the inspect, the plane that you drew again.
Yep.
So that's an operation that's cutting the shape. You would just turn it off if you wanted the whole thing back.
Correct. It's a visual aid only. It's not actually cutting the part.
Okay.
Okay. So in fact, I did 2 of them. I hid one. Now I've hid them both. They're still there. I can bring either one of them up again. They're parallel to each other. They're 2 separate ones in this case.
Right. So you could just have a bunch of those and to look at different things and then turn them all off again. And
yeah. So one thing I typically do with a part like this, and I didn't do it in this design because I want to get into that level of detail right now, but I like to use the origin planes as planes of symmetry when I have symmetry in a part. So in this case, I would typically start in the middle of the base. So, and the easy way to do that with a rectangle in Fusion 360 is there's a center drawn rectangle. And that makes life really easy. And then you can use those planes to mirror later features. So you can do if you have a part, we have some complicated features that are mirror images on both sides of the part. You can define it all on one side and then just mirror it across. So
I think words kind of lose us without the picture.
yeah, I'll have to demonstrate that at some point. Doing a mirror. I'm going to do a mirror in the next section right now. As soon as we're done with this, I'm going to go do the top-down parametric bookcase, and I'm going to include a mirror feature in that case.
Hey,
And,
Tim, could you add one more section just so we can watch behavior in the browser?
Sure. So I'm going to go to Inspect, Section Analysis. In this case, I'm going to use, say, the XZ plane and go in like this and see what it's doing. Now, if I turn both of these, oh, evidently I can only have one section on at a time.
And it didn't actually appear in the browser until you clicked OK at the end. So that's the
Right.
static position that it retains is the final position. Okay.
Correct. You can edit the dimension, of course, like anytime. But what I'll do, sometimes I'll have a section in here, and I'm not sure if I can rename them. Yeah, I can. So I might have a front-facing section, a side-facing section, and a top-facing section, so that I can easily go in and interrogate my part or assembly to see what's going on.
When you do get,
I have, oh, go ahead.
go ahead.
Oh, I have a question. When you are designing a part that has symmetry, we started at the origin on this and say worked in the positive X and Y direction. If we're just for symmetry, would we want to say we're going to be incorporating mirrors and flips about our symmetrical origin? Would we not be going in both a negative X and a positive X?
Correct.
Half the X of what we would want our total part to be?
Yeah, there's a couple different ways you can do it. And that's the way I typically prefer to do it. I see some people do it. The other thing I see people do is they'll work in the positive XY plane, and then they'll insert the plane of symmetry. And they might use a mid-plane or something of that nature to create it so that it can follow, or they might use parameters. But I prefer to use the positive and negative XY planes to reflect my symmetry and have the origin in the symmetric center of the part.
Got it. Okay.
But it's more a personal preference.
Okay.
Howard, did you have another question?
Yeah, when you do get a chance, you went down to the history on the bottom.
Mm-hmm.
And I was wondering if you could spend a few minutes explaining how that history is used.
Okay, yeah, the history, the timeline, they call it, is the chronological sequence used to define the part. In Nancy's language, we're programming the part, and this is one subroutine following another subroutine following another subroutine. Although there's no recursive programming here, it's all straight linear code. It's very simple. And so this was the first sketch I did, and I can do a few things here. I can edit the sketch. I can select a different plane. Because one thing that happens, we haven't really talked about parent-child relationships in here, partly because during quarantine with all the kids at home, that might be a sensitive topic. But in the context of CAD, parent-child relationships can be kind of important, because when you define a feature on top of existing features, you want to make sure that you're referencing, you're using your design intent in what planes, what surfaces, what faces you're referencing. Because down the road, if you make dramatic changes, that face or plane might not be where you now need it to be. So a couple things. One is maybe you initially didn't really reference the appropriate parent feature or parent face, or your design changed so much that your design intent changed, in which case you need to redefine some things. So sketch plane is a classic one in that case. Sometimes we'll just grab a convenient sketch plane that's in the right place, but really it isn't the appropriate parent for the sketch or the appropriate parent for the extrusion feature. So we can edit sketch, we can redefine things. There's a few other, we can suppress features, get a little more detail on them. And so that was the first sketch, and then that was the first extrusion. And we can play the part. If we go back to the start, we can advance. Now sketches are hidden at this point, so we don't see that sketch. We advance, there's that first extrusion. I'm going to turn the section off for now. And then here's that fillet. And here there's a sketch, which actually, let me turn the sketches on so we can see them. There's the second sketch. Actually, let me start over just so we can see the sketch part of this. So first, we got the first sketch. That became an extrusion. We rounded the corners. That was our next sketch with the offset edges. And then this was the cut. Here's the shell. And then here's that little round that I put around the top edge. So the timeline makes it really easy for us to go back in history to edit things. If I come back here and I go, you know what? I want to change this fillet. Here's the fillet. Let me hit edit feature and change this value from 30 to 20. I'm going to say OK. It's going to change that to 20 and then refresh all the features after it accordingly.
Question here, this is Pete. I'm seeing 4 black dots. What do those mean?
Those are the center points for the arcs in the drawing,
I see.
in that
I
sketch.
see.
That's part of the sketch. If I turn the sketch off, those will go away.
I see.
Normally, by default, Fusion 360 turns the sketches off when we're not using them.
Okay.
Okay, once we've used a sketch to create an extrusion or a revolve or some other feature, then it hides the sketch for us. But they're always there. We can bring them back.
Okay.
Okay. Any more questions on the basic sketching functionality and any of these features that I've demonstrated so far?
Yes, this is Jim. I have a question. If you go back in time and you change something which is impossible later,
Yep.
what kind of error messages do you get or what shows?
Very good question. I'm going to go back to this. Well, actually, let me do it. I'm just going to edit this fillet here. And instead of 20, I'm going to change this to 5. Oops, not 50. 5. Okay. Oh, but that was an outside. I did that as an outside. Let me undo that. Sorry, I'd forgotten that we changed the shell to an outside shell. So first I'm going to edit this shell, make it an inside shell with a thickness of 10. Okay. Now, one thing, we'll see what happens. Is this going to fail? Actually, it might not fail. But when I change the fillet to too small of a number, actually, let's change that to 5. No, it didn't fail. It just makes sharp corners in there. I forget how to make it fail at the moment, but generally what it does is in the timeline, the feature will be highlighted in yellow with an exclamation point. When it happens, you'll get a little message over here telling you there was a problem. And if you click on it, it'll give you more detail. I'll try and come up with, off the top of my head, not coming up with how to create what I can do here to make something fail.
What if you made one of those? What if you made one of those fillets like 200? It's just an outrageous number.
Yeah, then the fillet itself would fail.
Okay.
So let's try this. So right here, it gives you an error, tells you it can't be done. And actually tells you what to do about it. Try adjusting the size, deselecting some of the edges.
We can't see that error. We can't see that.
Oh, the error, yeah, the
It's-
error message isn't popping up.
It's hidden, yeah.
That's the downside of the way I'm sharing my screen. Let's see if I can.
Actually, we do have a control on our side, Pete. I don't remember how to turn it on, but you can have your list of people who are participating be a side panel built in. Does anybody on the call here know how you turn that on? Because it is helpful to be able to see Tim's full screen, and I know that I happen to have that right now. Is it when you go to full screen?
I just went full screen on the secondary screen and I saw that error message.
Just lost everything.
Oh, you did it? I just turned it off. So you can do that even though I don't.
Yeah.
That's interesting.
Yes. So go to full screen, Pete, and you should be able to see both his full screen as well as the participants on a side panel.
I am in full screen, but I still see but that error message was underneath the pictures of all the participants.
Oh, okay. You'd have to just move the participant frame
Oh,
away.
I see. Okay, I can move that. Yeah, I got it. Okay.
Well, there's also, though, there's going full screen, and then there's telling the app to be full screen. And when the app is told to go full screen, it makes Tim's full screen available to us and puts the participants in the side panel. I won't distract anymore. I just wanted you to know it's possible, Pete.
Okay, yeah, that's what I've done for right now. Now, let's see, here we got some weird stuff going on. I changed those fillets to a number that just kind of doesn't work very well. And where we ran into problem was this fillet's kind of ugly. So if you look down here, you'll see this fillet is highlighted in yellow. That tells me that it's unhappy. I think what's happened is the edge I selected to make this fillet initially is completely gone now.
And the lower right-hand corner has a cautionary note down there for.
Right, it says one warning, fillet 2. And when I bring it up, it says 7 reference failures, the edge reference is lost. Okay, so that's the kind of thing that happens if you go back earlier in the timeline and make a change that's incompatible with something later in the timeline. So good question.
Thank you, Tim.
Welcome. Okie dokie. I think I'm going to move on to the, any more questions? I'm going to move on to doing the top-down and parametric version of the bookcase. So starting a new file, I'm going to save it initially, calling it bookcase 2. And first thing I'm going to do is create, no, it's not the first thing I'm going to do. I'll take that back. So I want to think top down about this bookcase. I want to design from a point of view of planning, and I want to use parameters. So the first thing I'm going to do is I'm going to go into the modify menu, and I have a change parameters option. And that brings up this dialog box with parameters, and there's nothing in it yet. And I'm going to add some user parameters. So the first thing I'm going to add is height. Oh, you know what? I just noticed we're in millimeters. That was a good reminder. I'm going to, before I go any further, I'll go into document settings, units, and change it to inches since all my lumber comes in inches. So let's go back, do this again, change parameters. So the default will be inches now. And I'm going to say height. And let's make that 55 inches. I can put in a comment if I want. This is overall height. And I'm going to add width of 40 inches. I'm going to skip the comments now that we've seen how it works because in the interest of speed. Depth, oops, depth, and let's say we're going to use, I'm going to use 2x12s for the side panel this time. So that's part of my planning. So let's say 11.5 is my depth. And in this case, I'm going to say depth not including back plate. Because I'm thinking this through. Hey, I want to use this depth to control my materials. And what else is am I going to add in here? I'm going to use dados in this case. So I'm going to do something I'm going to call Dado Depth. And let's use 1/2 inch. And you'll see I typed in 1/2 because it does math. Okay, now I'm going to think about the material I'm using. So
Tim, this is Jim. A quick question. It looks like you didn't put a space between dado and depth. Do your names all have to be consistent with no spaces, or any other characters not allowed?
That's a good question. Watch this. I'm going to add in something for side And I'm typing space and nothing's happening. So the answer is yes, you can't put spaces in here, but don't worry, it won't let you. So what I tend to do is I use sort of what programmers might do and capitalize the first letter of each word in the variable name.
Camel case.
That make sense?
Yes, thank you.
Okay, and side panel thickness, I'm gonna say 1.5. What else do I have to control here? I have a shelf thickness, and I'm gonna use 3/4 for that. I'm sure there's other parameters I can't think of right now. And I'm going to continue, and I'm going to come back and deal with those on the fly.
So a quick question, if I was going to bring in a component and then reference or function dimensions off of my new part to the imported part, can I refer to variables on the imported part?
If the imported part is a Fusion 360 part, then I believe you can, yes.
Oh, right.
If it's not, you might need to create some driven dimensions. And like if you brought in a step file, you might be able to create some reference dimensions on the step file and use those in expressions. I'm not exactly sure. Now you can do a few other things in here. Like you can have the formula in the expression column can involve existing parameters.
Yes, I had seen that, like the depth being dependent upon the height or the width type of thing. Yes, right. Okay.
Exactly. Okay. So you can use that when you're entering dimensions, and you can use it here in this table as well.
Got it.
Okay, so I'm going to start on my, I think that's my key dimensions. I think I have most of what I need. I know there's going to be some I'm missing, and I'll figure them out on the fly. But I have I know, there's another one I'm missing. Real obvious one. Let's put in the number of shelves. Okay, and the units in this case, there's no units. And I'm going to say 5 shelves.
Very close.
Okay. So now I'm going to start. Well, for me, when I'm thinking about this thing, the way I'm going to build it, I'm probably going to build the side panels first, and then put in the shelves, throw on the top, the back, a kick plate maybe, some things like that. So when I think about the kick plate, wait, there's something there that's a key dimension, and that is the height of that first shelf, right? Let me put that in too. So I'm going to put in first shelf, and let's say 4 inches. Okay. Now I'm going to create a new component, and this new component I'm going to call side. And the parent is the bookcase, the top level. That's correct. Activate. Now it creates this new part, and it activates it right away, right? And it's a good idea every once in a while to hit save. In the old days, we used to save a lot because computers crashed a lot. They crash less frequently now, but I actually did have it happen today. Coincidentally, right after I'd done a save. So it would be great if that happened in a lesson to make the point. But when you save, you can put in a description of the version or the milestone so that you can refer back to it, because you're going to get a version saved. Every time you save it, all the old versions are still available to you.
So that is a description that we can reference back to what likely took place of consequence since the last save?
Yeah, so you put something in like the milestone. So let's go to, where was this? Bookcase 2, I called it, right? Bookcase 2. And so we have two versions here. The first one I saved 8 minutes ago, and the second one's this one. Now, I can come in after the fact too and create a milestone, which I can use as a description. And I'll just say a milestone name is initial parameters defined. I'm going to create that milestone, and now it'll appear here as a milestone. And I can come back, I can pull up any one of these earlier versions in another window. And I can make an earlier version the new active version. If I go off and try something, decide I don't like it, I can come back to an earlier version.
So you can actually create a tree from a common file then?
Correct. Which can be useful for doing a family of similar parts of different sizes. Say you were doing fasteners. You could do one screw and then do a whole bunch of different versions, the different sizes of screws, very, very quickly and easily using your parameters.
Was that side one a new component?
Side is a new component, that's correct. And one means it's the first instance of that part. So I'm going to sketch, I'm going to use the XY plane. But remember, I said I like to use the planes of symmetry that are in the part. So I'm going to come over here and grab a 2-point rectangle and make this rectangle here. And what I'm going to do for in this direction, I'm going to say this is the depth. As soon as I type a couple letters, everything that has those letters in it comes in. DE in depth, DE inside, DE in depth pop up, and I can just grab this. Now I'll tab to this one, and this one was a thickness. I'm going to type TH, and here it is, side panel thickness. Right now, the only thing is my depth went in a different direction than I meant. I just moved my mouse up, and there it is. And I'm going to go with that. Now you see it shows me my dimensions, but it puts fx in front of it as the function symbol. So it's 11.5 driven by a function. It's 1.5 driven by a function. Now I'm going to add another dimension from here to, oh, come on, I need to turn my origin on. It doesn't like picking the origin first, so what I often do is I pick sketch dimension, pick the plane or axis first, and then pick the geometry. This is just, I don't like it. It shouldn't be that way necessarily, but that's the way Fusion's working. So I'm going to go here, and for this dimension, I'm going to put in width, width divided by 2. And there it is, 20 inches. Okay, that's my sketch. I'm going to finish my sketch. I like to go back to the default view so I can see what's going on in the isometric view. And I'm going to create extrusion. And the height is going to be, I want to make sure it goes in this direction. And I'm going to put in a height, which is height. Now there's a different ways I can define this. I could say that I'm using this height to drive the length of the side panels, but in reality, the overall height includes the top. I'm going to have a top plate on here. So it's partly how I want to define it. So I'm going to say that my top panel is going to be, top plate's going to be made out of the same material as the shelf. So I'm going to say my the length of my side panel is the height minus the thickness of a shelf, because that's my design intent. Oh, come on. Did I type something wrong here? What's going on? I think maybe.
Do you need an equals and before height or something like that?
No, I don't. I think maybe it's
The capital
case
letter.
sensitive. It's case sensitive. So there's the height of my shelf. I want this as a new body inside side. And everything else looks correct. You say okay, and there's my side plate. One thing I could do at this point if I wanted, or later in the stage, I can always decide what the physical material is going to be. And let's say that I'm building this out of white oak. And there's my board. Okay, I'm gonna save at this point, and I'm just gonna go with that. I'm not gonna describe it. Now, next thing I'm gonna do is put in some shelves. So I'm gonna create a sketch on this surface. I'm gonna zoom in here. Keep in mind, I told you I was going to intentionally make a few mistakes in here. That's not just an easy way to cover my butt. That actually, I'm serious. So that seems to be there. And I'm going to add some dimensions here. So this dimension is going to be my shelf thickness. And I want to add a dimension from here to the base. And that is going to be my first shelf parameter. Okay. Finishing my sketch. And what did I do wrong? I have a sketch inside side. That's not what I wanted. I wanted this to be in a new part. Oh, I was zooming along too quickly. Let me create a new component. I'm going to call this component shelf. And parent, I want not to be side, but I want the parent to be the top level. It's not a subassembly, so it's the top level. Activate. Okay, and you see that shelf is outdented to the same level as side. It's not indented under there.
How did you enforce that hierarchy so that it moved out?
What I did was, and you can move it after the fact, but I selected the top level as the parent.
Got it, okay.
Now I can move it in underneath. Hold it, I can move this to be underside somehow. Thought I could. Maybe, wait. There is a way to restructure this. Somehow I'm doing something wrong there.
I don't think it can be active when you do it, Tim, if I remember right.
Right, I have to be active up here, don't I?
Yes.
Now, can I move it in there now? No, or do I need to be active here? Huh, not quite sure why it's not allowing me to do that. This sketch, by the way, is in the wrong place, so I'm going to delete it.
You basically told us we need to get it right the first time.
No, you don't. It can be moved, and I've done it before, and somehow I'm missing something right at the moment. But I'm going to come back here. I'm going to, now that I activate shelf, I'm going to redo this sketch on this surface. I'm going to sketch a rectangle from here to here, and I'm going to define this as the shelf thickness, and I'm going to define this distance here as first, oops, as first shelf and finish my sketch. Now I'm going to extrude. Actually, let me go to this view. I'm going to extrude this profile. Now I'm going to do something that's a little bit complicated here, so I'm going to slow down here. Plus I make fewer errors that way. The start, I'm not going to start it right at the profile plane because remember, I wanted to use dados this time. So I'm going to offset the plane in this direction, which is negative. And oh, actually, that's doing the, that's the wrong thing. I'm going to offset it by Dado Depth. Now that went the wrong direction for me, so I'm going to do, and I can confirm that by looking from the front. I want that to be minus Dado Depth. Now you can see my shelf is starting back inside the wood. And then the length overall is going to be width minus 2 times the side panel thickness. And I just realized I typed in the whole word width, which I shouldn't have done. I should be using, selecting this so that I get proper capitalization. And I'm going to say plus 2 times the dado depth. That should be the correct overall length of my shelf, right? The overall width, come in by the thickness on both sides, go out by the dado on both sides. Everybody follow the math?
Was that minus the thickness? Could you go back and just
Yes.
the operator?
Yes, it was minus 2 times the side panel thickness.
Got it. Great, thanks.
Yep.
And if you had a real complicated formula, is there a way to something you can click that would give you a bigger area to be typing all that in?
That would be really nice, wouldn't it? I don't see that there is. Oh, here it is.
Okay.
There was that little, those little lines up above there. Yeah. Okay. And so I've defined my offset and my distance, no taper. It's a new body inside shelf. I say okay, and there's my part. Now, what I noticed when I picked the part is I have an interference. Okay, so I'm going to create multiple shelves. So what I want to do is create, first of all, I like to select, I want to create a pattern of shelves, but I don't do that within shelf. Don't want to make the mistake I did with that earlier sketch. I'm going to come up to the upper level and activate at the top level. Now I'll select the shelf, create a pattern, a rectangular pattern in this case. And the object is selected because I highlighted it first. The direction, I'm going to use the Z-axis. And I want the type to be extent because I'm defining it. I could define it by increment, my selection of space between shelves. But I decided I'm going to define it by the height of my piece of wood first. And then however many shelves I want. And that'll, the interval will drop out. So I want the ability to suppress the quantity I'm going to put in. Remember, I made a parameter for this, number of shelves. However, if I do 5 shelves in my extent, then the 5th shelf will be at the very top. I don't really want that, but I want that 5th space. So I'm going to say number of shelves plus 1. as the quantity. The distance is going to be, and again, I get a little bit complicated. It's going to be height, but, oh, that's too high. Why? Well, I have the first shelf height. So I'm going to say minus first shelf height. Is that right yet? I don't think so. I know it isn't, but I'm going to change the view to make sure. And it's because of the thickness of the shelf. So I'm also going to subtract shelf thickness. Now I have an even interval between each shelf, including the very top one. Now I want to select this check mark to turn off the top shelf because I don't actually want a shelf there. For some reason or other, Fusion 360 doesn't do this very well when you're looking at it head on. But when you change it to the default view, now you can toggle that off. Okay? That looks like what I want. I'm going to say okay.
Toggling it off sounds as though it's simply not visible, but it's there. Are you saying it's no longer a body inside of this component?
It's, well, in this case, we're patterning components, but
Okay, so
it is no longer a component.
Okay, good. All right, great. Thanks.
And in this case, I did the one on the end. You could do one in the middle if you wanted one double height. And that's important when you're doing, sometimes you do circular patterns and you don't want the full circle. You want to drop out one or two key fasteners, polarize it, get around something else that's going on, whatever, orient it, whatever, okay? Now, what's wrong with my design so far? Well, I have an interference all the way along the side panel, right? I want to model the dado cuts. And there could be a couple different ways to model the dado cuts. Any ideas?
Mirror that one panel as another component on the opposite end?
Well, I'm going to mirror it later, but the
Dado
side panel doesn't have the dado cuts in it yet. See that?
Exactly.
I think you can use
Got
the
it.
solid tools in the subtract.
So I'm going to revert the position. Yeah, one way would be to do a solid subtraction. And that's a very useful thing to do in a lot of cases. The issue I have here is Fusion 360 isn't robust enough to pattern the component subtraction. So I would have to do it for each shelf. And then it breaks if I change the number of shelves. So that doesn't give me a robust model. I mean, I like that approach from a philosophical point of view, but it just doesn't cut it for me.
This would be where your parameters come in useful, right?
Yeah, so we're going to, you know, when we get finished, we're going to play with the parameters a little bit. And you can see some of the things we do. But you sometimes knowing the limitations of the tool gives you some idea of how you're going to approach making a feature like this.
Yeah, I'm sorry, Tim, is the question currently, how do we get the dados into the side panel?
Yep.
Okay.
So the one suggestion was mathematical subtraction, and it works, but you have to do each one individually. And then if you change the number of shelves, you have to manually go in and take care of the problem. So instead, the simple approach of just making an extruded cut is the correct one. So what I want to do here, though, is I want to make sure I activate the side component. I don't need to see the rest of this in the browser. So side is selected. And now I'm going to create another sketch. And I'm going to sketch on this front surface. And I'm going to zoom in here. And, you know, it's a little bit, I guess since I put the material finish on there, it's kind of hiding it. But we know it's there. And what I'm going to do, I'm going to show you the project feature. So I'm going to project some lines, but I'm going to use construction lines here. I'm going to project from the shelf into my sketch these 4 entities. And then I'm going to use those entities to snap actual geometry to. Okay? And what you see on my sketch is, you see these lines have snapped to be horizontal, vertical, horizontal, vertical. But these constraints here, these constraints here tell me that I see that shape. What's that constraint? That constraint is coincident. So the corners are coincident here, corners are coincident here, and that fully constrains my rectangle.
Before you had drawn that, you used a word that you said it was there was a problem, but I can't remember what the word you said was. But could you see that in the history that there was a problem because you didn't have the dado, or you just knew that?
Actually, that's a good question. I knew that we offset the shelf into there without making the dado first, and there may be. Let's see. Do we have an interference check? I'm used to having an interference check. It doesn't look like I have one, but I'll research that to see if I can find some way to automatically check for interferences, because that's very valuable in a lot of design.
Go back to inspect.
Yeah, it's
Go back to inspect.
Interference
Second
right there. So if we do interference here, and we select shelf 1 or side and shelf 1. Let's see what it looks like. It's showing us in highlighted blue some interference, and it tells us that we have 4.3 cubic inches of interference. Okay. I guess I'm not sure that there's a global check, but I need to play with that tool a bit more here to see what all it is. But yeah, good question, and thanks for the tip.
Were not the shelves defined with when you defined their width, if you will? It was plus 2 times the Dado depth. That expression.
Correct.
So when you duplicated it 5 times and removed the top one, doesn't that automatically account for the Dado depths and all other 4?
Yeah, they all have the dado depths, but the side panel doesn't actually have the dado cut into it.
Oh, okay.
Right? So what I'm going to do now is I'm going to extrude this profile, this direction, and rather than quibble with the depth, I'm going to say all the way. And it's a cut, and then down here is objects to cut. And this is important, because if I don't do anything, it's going to cut out of both objects. Well, I want it to cut out of the side, but not the shelf. Now when I do this, if I pull the side away, you can see the dado cut is in there. So what do I need? Well, I need to pattern that all the way up as well. So I'm going to create a pattern. Now this time, my context is side, and that's okay. So I'm going to, because it's a feature within side that I'm patterning. And in fact, it is this feature. So I'm going to select it from the timeline. I'm going to do a rectangular pattern. Now it tells me some components have been moved. You can capture the current position or use the previous position. I'm going to say continue because I just pulled it away to have a look. It's not really my design. So we have this. Again, I have a direction. My object is selected. It's that feature. I'm going to grab this as the direction. The extent is what I want. The quantity, again, is going to be number shelves plus 1. And the distance is going to be height minus first shelf height minus a shelf thickness, just like it was when I patterned the shelves, so it should be exactly the same in the one direction. The other direction, don't really do anything. In reality, it's 1 in the other direction. I say okay. Now let's see, did that work? There it is. Okay, so now I just pulled the part away to have a look at it. I'm going to revert the position back in place. And now I want to create the side on the other side. So what I'm going to do is I'm going to change. Again, this isn't with inside, this is at the top level. So in my top assembly, I'm going to select side. I'm going to create a mirror. So it's already selected the component because I highlighted before I did it. If I hadn't highlighted, I could pick it now. I'm going to go pick the mirror plane, and I'm going to use this plane here, and bingo, there we are. And down here you see side mirror. So it's created a new part, even though these parts are symmetrical front to back as well. So it isn't a different part, but had, for example, had the dado not gone all the way, or if there were some asymmetry to the part, then the side mirror part wouldn't be identical to the side part.
And that just mirrored across the axis, or the
Across
plane.
this plane, right?
Yeah, okay.
So for example, if I drilled a hole here, inside mirror, the hole would still be at the back, so they wouldn't be identical pieces.
Mirror image.
Right? They'd be mirror image parts. They, in this case, they're both, but that's a coincidence.
So Tim, this actually takes us back to the very, very beginning, because when you chose, your intent was to make this thing symmetrical along the green axis.
Correct.
So, because you knew down the road you want to use this mirror feature, and you would be using that axis to be the center point of the mirror. Is that right?
Correct.
Okay.
Now, if I hadn't done that, there's still things I could do. I could define an offset plane and use the parameter and say that the location of the plane, it was offset by width divided by 2. Right? So I can just grab this guy right here, go construct offset plane, and put in width divided by 2. There's my offset plane, and I could have used it. That also works.
Got it.
That's kind of a personal preference thing.
Hey,
There's
Tim,
a mid plane too.
Pardon?
There is also a mid plane. You can construct a mid plane.
Correct. To use the mid, I could use the mid plane now that I've already mirrored it. Or I could use a mid plane which is between the plane on the edge of one shelf and the other end of the shelf. And then I would have a mid plane that I could use. That's true. So there's multiple ways to achieve the symmetry.
Tim, could you just show us one more time again where that function is that allowed you to repeat these shelves upward? Was it a project function?
No, it's create pattern.
Pattern. Okay, great. Thank you.
Now, when I did the dados, I took the shortcut up here. But in the menu, it's down here. You have the option of rectangular pattern, circular pattern, and pattern on a path. Okay, we could go ahead. Putting the top plate on and the rear plate and the kick panel are pretty straightforward, pretty much as one might expect. But before we get there, I'm going to save, and I'm going to flex my model. I want to make sure that the parameters do what I wanted them to do. So I'm going to go to modify, change parameters. And when my parameters come up, let me say, okay, what happens if I change the height to 80. Does that look like what I wanted? Does it look like the spaces in between are still consistent? There's room for the top plate. I still have 5 shelves. Yep, everything looks like what was intended. Okay, let's try the next one. Modify, change parameters. How about the width? Let's make the width 65. Yep, this time it did. Okay. And then modify the depth. So let's say instead of using 12 by, I start to use 10 by, so I go to 9.5. Let's see what happens. Oh, I was expecting an error there and I didn't get one. So when I sketch the shelf, the end points align to the edge. Sometimes you'll do this and you'll find, oh, the shelf didn't change with it. And then you'll need to go into the initial sketch and add the constraints that you assumed had happened and didn't. So often I have to go in there and add a collinear constraint. I think that happened last week. So in the sketch menu, edit the sketch, and then in the sketch menu, add constraints in to reflect the design intent. What else do we have for parameters? We could say number of shelves. Let's make it 8. Aha! There's something. Remember, we suppressed the 5th shelf.
Right.
Right? So, you know, we could have not added the extra shelf to suppress by having a really complicated formula that computed the space and went down from it. So I like to flex my models to see what happens.
Could you go back in history and undo the suppress the 5th shelf?
That's a really good suggestion. Interestingly, hang on. Oh, right, on the, hang on. Let's see what's going on here. Why did it? So with the dado cuts, maybe we didn't suppress the top one because it was off the top of the side panel anyways. But yes, if we go to this pattern feature, we can come back here. We can turn this back on and turn this one off. There we go. Yep. So it's always good to flex your model when you have, it's kind of like, I don't know, it's not unit testing. What kind of testing is it? Bounds testing. Nancy, you correct me here. I'm not a programmer.
That sounds good.
Well, when you said flex, I thought you were going to contort it and try and do like a shear wall, because we don't have a shear wall on this thing.
We don't, yeah, no, by flex, I meant flex the mathematical model.
Got it, yes, okay, yeah.
But yes, I would put a back plate on here. If I were doing the actual design, there would be a back plate on here, a top plate, a kick plate, all that stuff is there. But I think the mechanics of making those components doesn't bring enough to the table tonight to bother going through there. I think we've hit the meat of the matter right now, and I want to throw it open for questions.
You kept moving that one tall end board off. How was you moving that away to take a look at it?
So I was just grabbing it and moving it off. So click, hold.
Why is it moving without doing the move tool?
If you do the move tool, you're actually moving it in the design. This is more like an inspect move. And then when I revert, it'll pop right back into place.
Oh, okay.
So it's just, it's kind of convenient to have a look at what's going on. Hey, for my Dado part, you know, if I use the depth for the, say I've used a depth and I somehow got the depth wrong, when I look, I would see a problem there. So it's an inspection tool.
So when you move that, everything stays planar, and it doesn't get out of alignment.
Yeah, it seems to move it, but
you can move it in 3 dimensions.
Yeah, but I can't. It's not rotating.
Right, but if you just leave it cockeyed,
yeah,
then you hit to put it back in place. It will go back in place.
Right, and depending what I do now, if I go to do some other feature, it might come back and tell me. Like we saw this earlier when I went to pattern it. It came back and went to pattern the Dado. It came back and said, "Hey, you've moved the part. Do you want to capture the new position or do you want to continue in the original position?"
Okay.
And I said continue, and it bounced back.
Yeah.
So it's really a neat tool to quickly use the shift middle mouse button to orbit to see activity, see what's going on. Pull this one out in a way and see how it looks without this one.
Can you hide and unhide things?
Yeah, so if you come over here to the browser, the little visibility, that's another way to do it as well.
Little eyeball there, yeah. Mm-hmm.
Yep.
Okay.
And then the positions, I'm going to revert everything right back, and I'm going to go to my home position, and boom, there I am.
Mm-hmm.
So what I've done is I've defined this, I've done the top-down design approach. I've thought about, I had a rough idea what my bookcase was going to look like, enough to figure out what most of my relevant parameters were. Now, when I go to put in the kick plate, for example, I might realize, I want the kick plate to be recessed, and I don't have a parameter driving that. I don't have to have a parameter. I can put in a number, but if I want to maintain this purely parametric model, then I should do that. And actually, I'm going to do it because it demonstrates one little point that I haven't really demonstrated yet. So I'm going to create a new component. I'm going to call it kick plate or kickboard. Kickboard, and I want the parent to be bookcase. Yep. And okay. Now I'm going to sketch, and I want to sketch using this front plane. And if I'm being pedantic, I really should use this plane rather than another component. And I'm going to project a line, project construction line from here. And I'm going to project a regular line here and here. And I'm going to sketch a line from here. Actually, I didn't really need the construction line to here. And I'm going to do a line from here to here. And I see the color change, so I have a closed surface. Now I'm going to extrude. This is my profile. My profile has been selected, but I don't want to start at the profile plane. I want to start back in a little bit. So I'm going to offset, and And I don't have a parameter to drive that at the moment. So I'm going to say I want to offset it by 1 inch. And then the thickness of it is going to be same as a shelf thickness. And I'm going to say OK and see if that went where I meant it to go. Yes, it did. But you know what? I want this offset to be driven by a parameter. So I'm going to go back to my parameter table. And what I see on my parameter table is under the model parameters, see, I can see various parameters in here, and I can see which ones are driven by what. And under kickboard, there's an extrusion, and under that extrusion, I have an offset of 1 inch. But it's not driven by a parameter. Now it's called D30. And here's a tricky thing. It's tempting. I could just go in here and call this kick offset. Okay, and that's going to work. However, there is something really important to know about doing this. When I do that, this parameter is a local parameter to kickboard. This parameter is not available to me in the rest of the design. Okay? If I want to use a parameter here that's available for some other purpose, I better put it up in the user parameters so that I can access it in other components. Here I can only access it in this component. It's a local variable as opposed to a global variable. Does that make sense to people?
Mm-hmm.
Yeah.
Yeah. So.
Is there a way to move it up from down there, or do you have to?
No, there isn't. You have to basically, I would come back in, change this back to D30. I would come up here, add the parameter, call it kick recess, give it a value 2 in this case maybe, say OK, and then come down here and in here put in kick, select the kick recess, and now it's going to be driven by that. And you see it moved back to 2, which I had given it the value of.
Okay.
Sorry.
So it was not at the same hierarchical level as, say, shelves?
If when I went in, if I have the option which hierarchical level to define it at.
Right.
So I like to define it as a user parameter to make it global to the design.
Right.
If I had defined it down here within kickboard extrude 1, then it's a local variable.
But is it not under bookcase 2?
It's way below bookcase, but like if I wanted to use that variable inside or shelf, I wouldn't be able to.
Oh, okay.
Because they're out of it's a different branch.
Okay, all right.
It's a different branch in the hierarchy.
Got it, okay, got it.
Is there a way to save the parameter table to be able to use in other jobs?
If you use a component here, or if you use this design as a sub-assembly in another design, then these parameters should come with. What level of global application they have, I haven't actually tested. That's a very good point. I'm not aware of any way to specifically like export the parameters. There may be. I haven't figured it out yet, if there is. But it's a good question. I don't think it has that power.
Okay.
But I could be wrong.
Do you know what happens when you make things favorites? What does that get you? As far as in this dialogue here, it's got favorites and it's got stars and.
Yeah, that's a good.
It puts it up there, but I don't know what that gives you really.
That might make them more global.
Yeah, that's interesting. Maybe it does.
Yeah, good. Yeah, that's a good point. I haven't played with that yet.
Tim, is it more like a thumbs up or a heart or a plus?
It's BFFs.
Okay, okay, good.
That's a good question. I'm gonna look into that and report back to the group. And export parameter lists. Okay, good questions. I love these questions because you're forcing me to learn the program better myself, and that's the side benefit of teaching is you learn a lot about it. Anybody else?
How about the numbering of the shelves? Once you played around with the design, now we have from 9 to 15 instead of from 1 to 8 or whatever. So.
Yeah, that's kind of interesting, isn't it? Why did it do that? Let's see what happens if we change this back to 3. Huh. That's very curious. Let's get silly. Whoops, that's wrong place. Number of shelves. Whoops, not 112. Let's go 12. That's really odd.
Although when we went to the smaller number, it's as though it was using shelves that had been previously created. And when you went to a much higher number, it seemed to create new shelves. I'm talking in terms of the numbers.
Yeah.
Draw a conclusion from the way the list changed from one to the next, but it's just a guess.
Yeah, I think it's just a little idiosyncrasy in the program. Let's see if I just go down by a little bit now, what happens? Nope, now it gets even weirder.
Oh, yeah, the sequence changes, wow.
Yeah, I think the sequence may be thrown off by the suppressed one. I don't have a good answer. It's a good question, Sam. I don't have a good answer. I think it's just something weird in the instance numbering. It's hard to call it a bug because everything still works, but I would call it a glitch for sure.
It's only curious. It doesn't really affect the design.
Yeah, you're right. But it is very curious.
Hey, Tim?
Yep.
It's like they're local variables in memory, and based on the position, all those other numbers are still reserved for the old position. I think that's what it's doing. And when you went back to the original, like Travis said, the original 1 through 4, it just reused those variables. It's like there's a local
local stack.
Yes.
Yeah, it's like a local stack getting used there. Yeah, that's curious. Interesting for academic purposes. Any other questions about parameters, top-down design, the stuff that I demonstrated here?
I asked you this on the email, but can you make a cut list out of these now, or what?
You can, yeah. I'll just do like a 3-minute demo of that because I want to do drawings in a different class.
Okay.
But if we do a drawing from this design, we get to create a new one. There's a few variables here. We'll use B-size paper, ledger paper, 11 by 17, or 17 by 11 since we draw in landscape typically. And it will create a template drawing. The drawing package is very, very rudimentary. So it brings up a title, a background and a title block. And so now we can create a base view. And
Tim, where did you grab that from?
It automatically, I think it started out with the base view, but if not, you can always grab it up here.
Oh, okay.
So that's my base view. And you can change orientation of your base view. You can change the scale. let's change this scale to say 1 to 20. Few other options, display options and other things like that. Won't go with, like I say, we'll do drawing in another class. Then we can do a projected view from this. So that's a front view, here's a side view. And let's say we want to do another base view, and we're going to put it right here. But in fact, instead of a front view, let's do this as the northeast isometric. And there's a very simple drawing. I can come in here and add dimensions off the drawing that are not necessarily tied to my parameters, or maybe they are directly or indirectly. And I can insert a table, and we'll use this drawing view for the bubbles. Let's put the, oops, come on, table, and there it is. Now it shows you some, oops, shows you some bubbles. Let's see, can I move these around? I'm sure I can. So there we go. I always forget that it's a one-click operation in most cases. We notice these other materials say steel because we never changed them. But it does tell us the quantity of shelf is 10.
That's cool.
And so this is the cut list. And now you notice there's description in here. And I said last week that I don't like to put dimensions in the part number or part name. I like to put them in the description. So what you need to do is, I think this actually needs to happen in the design view. You can go into something like side, right click on it and change properties. And there's a description in here. And I'm going to say 2 by 10 by, in this case, for sake of argument, 60. Again, if I use this description and I change parameters, it's no longer valid. And I haven't yet found a way to pull parameters into drawing. It might exist, it does in some other CAD programs, but I didn't see it here. But now that I've done that, if I go back to my drawing, and I need to force it to refresh, which sometimes it gives you the ability to do that here. And, oh, I know, I think maybe I have to save it. I save this, then when I go back, it tells me, see up here with the link, it says, we're showing version 5, version 6 exists, the drawing is out of date. And if I tell it to update, now when I come down here, this description is in the description column. Okay. Very rudimentary drawing package, not a lot of power or flexibility there, but it does the basic job.
And you don't have to pay additional fees like in SketchUp to get a layout drawing.
Right.
Yeah.
So this is part of the standard functionality.
Yes, good.
Anything else? Okay, so we're a little bit late for the next stage of the class, which is combination of show and tell, demos, and happy hour. I hope everybody remembered the happy hour part.
I already finished my beer.
Okay, at this point, I'm going to turn it over to Mark, if I can figure out how to do that. Let me stop sharing my screen. And Mark was going to, Mark, can you share your screen and then walk us through The 3D print.
Let's see. Actually, never played with this before, but I'm sure I can. Save screen, right? Or share screen, right?
Yeah, share screen. And then there's a share button down in the lower right. I always forget to hit that.
Right there. So is that
Yep.
Did that work?
Yep.
Beautiful. Well, I'm nowhere near an expert on this, but as I told Tim, I've been playing around with it for a few weeks. I don't know if anyone's aware that Sketchup, I'm sorry, we've got Sketchup on the brain. Fusion Slicer has only been out since, I think, February, March. And when it first came out, it had some bugs in it that didn't work with the Prusa printer. They've since then put a patch out there that I've been playing with for the last couple of weeks. And I've just been playing with like little parts like this, just fun things to see what I could do that don't take a long time to print or anything like that. Before I used Fusion Slicer, when you're in your design mode, I mean, everyone knows that you can go down to your body, right? And let's see here. And on your body, you can save this off as an STL, right? And then from that, I just take it into the Prusa Slicer, and voila, that is the same workflow as everything else.
That was your old workflow, right?
That was my old workflow. I just wanted everyone to know that it is there, and that's what everybody I know used to do and before they introduced Slicer into Fusion. So now in Fusion, under the manufacturing tab, they've come up with their own slicer. And what you do is, has anybody used the CAM software for a CNC or anything like that?
Inside of Fusion?
Yeah.
No.
Okay, it's basically the same type of thing. So what you do is you go in and you do a setup. And over here where you select your machine, you can select milling, which is what you would do for your CNC, or you can select additive, which is what you do for a 3D printer. You then tell it what body you want to do, and oops, the additive must be selected. Okay, so I skipped over a step there because I was trying to jump ahead. So I go back to my setup, setup here, new setup, and to select my machine, I have the Prusa i3MK3S, and you can select that there. All that does is define the bed size. If you see, if I zoom out, it's basically defined the bed size and some various parameters that the Prusa uses. You can then go into here and edit things like, do I want to start my print on the platform or off the platform, stuff like that. Just to keep it really simple, we'll just come over here and we'll tell it the body that we're going, like select the two bodies that I want to do. So it says nothing, right? I click on what I want to select and I say that it's additive. The print settings are everything everyone's used to. These are the ones that I've kind of been playing with. FFS stands for Fusion Filament Fabrication. And the 2.8 doesn't work. The Prusa uses the 0.4 millimeter nozzle with the 1.75 filament. And so I've been using like the PLA here. You can select that. You can say okay. You can then come in and define your position, or I skipped over that when I did that. For under your print settings here, you can edit your print settings. This is kind of fun. This is where I think I mentioned last week that Fusion has a ton of extra parameters that Prusa also offers, but you have to be in that advanced part of the slicer, like all the different fills that you can put in. I just played with some of these because some of them look really cool and stuff like that. You can define your layer temperatures, the type of infill you use, your brim, the raft that goes around, whether you need supports or not, and all that kind of stuff, all in here. So where Prusa has a neat thing where you can just say basic, and it does all of this for you. Fusion has basics in here, but I find that you have to fine tune them a little. And what I did is I cheated. I went into the Prusa slicer and I looked at what they were and I mimicked them over here to make my life easy. So I kind of pirated them. So,
Hey, Mark, can you show us, obviously, when you're doing 3D printing, you're printing on the XY plane, and the orientation you have there is a little bit disconcerting for those of us who know about gravity.
okay. Yeah. So when you do your actions where you want to generate, let's see here. You want me to change the positions, what you want me to do, right?
I was hoping it was easy, yeah.
Yeah, so position right here, and it has the automatic orientation. And inside this orientation, you rank what things are important to you. And from there, you gotta select your model. I always forget to select the model. I don't know why it doesn't remember the model that you have. You think it would. And then you could come over here to your orientation, and your orientation results are here. And this is what you're talking about, Travis, where you want to be able to see the different orientations. What I didn't do is prioritize which one was which, see? So I could say, let's see here.
Actually, Mark, that's really cool, but I was just talking about the fact that the bed is on the right hand. I mean, it's sitting vertically as opposed to...
Oh, that's just because, see how the Z is straight up here?
No, I totally get that. I was just saying.
Okay, I apologize. So I'll get back out of
We'll
this.
do it upside down. That's even better, yeah.
Yeah, so I've completely messed it up now here. Thanks, Travis. I really appreciate it.
Just want to be here to support you, Mark.
So it's getting used to the same, what do you call it? Oops. There we go. Like that. That's what you want to see?
So is the XYZ in Fusion 360 the same as XYZ in the CAM manufacturer or the Prusa?
It is.
Or do you don't have to rotate or
No.
do anything funny things? So again, just defining from the get-go what plane you should be working in.
Yeah, this is actually the bed. It defined the bed. That's why Travis was getting really antsy.
Yes.
Defined the bed sitting out there in my XY plane, and I had it flipped up on edge. I've been playing with a bunch of different settings, trying to do crazy things. So, let's see. Right here's how you generate your G code.
So you had a little red indicator that there was a problem and you still needed to generate your G code, right?
Exactly. Yeah. It didn't want me to. Sometimes it's kind of slow. See how it's only at 72% right now? It'll finish here in a second. It's not the fastest G code generator. Remember how the old Prusa slicer was really slow?
Yeah.
And then they did some amazing things to streamline it. I think Fusion needs to work on a few of those type of things, and they're not quite there yet. It does have an excellent simulator though. It does the same thing that any of the drawings does, and it, based on the parameters I selected, that's what you're seeing, how it's starting to do the drawing. I'll speed it up a little bit here.
Hey, Mark.
Yes.
This is Rob. Hey, I was looking at this week, and when I activated, it told me I needed to add an extension and that it wasn't available to me except for a 30-day trial period. I would have to pay for a subscription because it's not available for hobbyists and small businesses. So I went on the website and researched, and it specifically says that. And it costs you a subscription fee if you want to use a manufacturing extension I'm talking about, not the other stuff where you exported it to the printer and all that. But if you want to generate a G code, you need the manufacturing extension. At least that's what they said on the website, and they gave me a warning that I was activating a trial.
See, all I have is the hobbyist version of Fusion. Is that what you have?
Yeah.
You have a hobbyist license? Yeah. When I went out to get, what I had to do is get the new slicer. The old slicer had a bug in it. The original one that Fusion brought out had an issue where basically it didn't level the bed and it didn't zero the machine, and it didn't preheat the head. But all those things have been fixed because I actually did a little bit of research before this, and I wasn't going to show this, but let's see.
Well, how long have you had it, Mark? How long have you been using it?
About 2 weeks.
Okay, so we'll see if after 30 days your subscription goes away. Just like that's what they warned me of. I'd have it for 30 days.
But Mark, just to be clear, right now you are able to take the model, slice it, generate G code, save it to an SD card, and put it straight into your printer, right?
Yep, I sure am.
Okay.
These are the lines that Fusion did not used to have that they fixed. So we can increase the size for you guys.
We're not seeing that screen.
Oh.
Choose screen, select and choose the right one.
I apologize. So yeah, it goes straight to the printer. The one thing that I don't like about the current Fusion slicer is it's a little slow, and the edge detail on real sharp edges isn't as smooth as the Prusa's is. But if you're gonna whip, the neat thing I use it for is you're gonna whip together a little bracket, or you're gonna do a little dust. I use it for a lot of fittings in the shop to go from one dust hose to another. You can whip out with a revolve command. You can whip out a fitting, and I use the shell command that Tim showed us tonight. You can whip out a setting and then print it out. You can do the whole thing, design it, slice it, and print it all in about 2 hours. And then I have a fitting for out in the shop.
Now, when you print it, are you downloading it to something, or are you going straight from the program to your printer?
No, I actually, it's one of the things I wanted to do. I haven't done yet, Howard, is to set my printer up with like a Raspberry Pi that's wireless so I can actually transmit to it. But since I've been lazy and haven't done that, I actually have to take the SD card out of the printer. You see that? And I put it in my computer and just copy the file that Fusion generated, and then I stick it back in the printer.
Sneakernet.
Sneakernet. Well, yes, but they're only about this far apart of my desk here. So.
Hey, Mark, just because many of us at the outset of this, when we were talking to Tim about what we'd hoped to get out of this SIG, we're saying we wanted to have one program to rule them all, so we could design for our 3D printers, CNCs, lasers, etc., in one program, output from that one program, and run the code successfully from that one program. Are you using Fusion 360 with your Shapeoko, with your Ruida controller laser, and with your 3D printer?
I am using it extensively with my Shapeoko, and now I'm using it for everything on my 3D printer. I just today started playing with the laser. It's a little different because what you're kind of doing is doing a drawing and define. It's going to be really hard to get me off of Lightburn. Lightburn is so incredibly powerful. It does so many things well.
Yeah.
That being said, if I get about 2 minutes, I'm going to show you guys something that's going to get you really, really excited about lasering.
Okay.
I'd love to see it. But just to summarize here, yes, you can go, if I had a wireless Raspberry Pi on my printer, I could literally go right from here, drag in. What I would do is I'd export the file to my directory, and I drag and drop it across to the Raspberry Pi, which would then hit the printer. But as far as let's see here, I'll show you quickly. As far as the milling goes, it's the same basic setup, but instead of additive, when you do your setup, and I'm sure Tim will go over this at length. This is really cool. When you come in here and you selected milling, then you're going to use the post processor for the Shapeoko. But basically, you'll do your setup in here. You'll select milling as your whatever, and then you go in and define your bits. Up top here is where you have all of your different types of tool paths. And one of the most powerful things, in my humble opinion, about Fusion's CNC is the adaptive paths are amazing. It does way better than VCarve does at figuring out a very efficient path to cut. It cuts quick, it cuts clean, and it's just really, really good at what it does.
So by adaptive, do you mean, for instance, if you did a large clearing operation with a 1/4-inch end mill, and you needed just to clear a few pockets with a, say, 1/16 inch it would know just what to do for just that one remaining portion for the 16th
It
inch of
does.
the mill?
It does a roughing pass it figures out how to do the roughing pass, and then it asks you how much material you want to leave for your final pass.
Yeah.
And it comes back and does a really clean final pass. So it'll go through and carve out massive amounts of material very, very quickly.
Yeah.
And then it comes back with the finishing pass, and it does either the climb or the conventional. Remember we were talking about that the other day because of the backlash on the machine?
Yeah.
And it does a really, really clean job even on the Shipoko. It's amazing. It was holding tolerances to about 1/10 of a millimeter when I was testing it.
Well, we don't all have the same shape Oko you do, which, by the way, if anybody's curious, you'll have a chance to see it on Saturday. Right, Mark?
I'm sorry, what? Yes.
Am I breaking up?
I did basically the same things that you did, Travis. I added the steel belts because they don't flex as much as the standard belts. But the one thing, when I want to finish, I don't want to take Tim's time up here. The one thing I had trouble with when I took my CNC class was the Z-axis. That's one of the first times I saw the Shipoko error out on that. And I think, Dellison, you had to fix that, and I came back to do my final project. So I went to the ball screw Z-axis now, and it's amazing how much downward pressure you can generate, and it doesn't have a problem.
Yeah. Like I said, we don't have the shape Oko you have.
That and I made it liquid cooled, so it's super quiet. I'll show you guys.
Like I said.
Can't wait to see it.
Saturday morning, 10 a.m. You'll see a whole bunch of CNCs.
It's funny because the you know how it has the little VFD, the little frequency drive variable. Yeah. It makes 5 times the noise of the spindle at high speed.
Huh.
And it's still quiet. You and I could sit here and talk while it was running.
Yeah.
It's about the same. It's about the same sound as the fan on my laptop is right now.
Crazy. Crazy.
All right. Giving this, I think I gave the screen back, so I think Howard wanted to show something.
Yeah. How do let's see. I want to show my screen.
So share
So
screen.
let me get there and let's see where is the one I want to show. There it is. Share. So we're in Aspire right here, but this is going to work the same in VCarve. And if I'm going over and I want to do some lasering, let me move my picture out of the way here. You'll notice over here on my menu, I now have laser cut and fill.
No.
Remember, he's got Aspire.
Oh, he's in Aspire.
I got laser cut and fill. I got laser pitcher. And I'm right now working on the beta with them for getting this up and running in VCarve and Aspire.
Mark, it's not only doesn't he have Aspire, he's got the beta version. I mean, this is just not even fair.
My hero. I love beta testing, Howard. I think it's cool because you get to break everything and get input. I think it's a fantastic.
Well, I found some literature on it, and it said that laser, and I'm thinking, well, where is it? Where is it? So I wrote them, and I says, where is it? They said, oh, it ain't out yet. And they said it's going to be a add-on that you got to pay for and everything. I said, well, I'm working on later. I'd like to be the beta tester for you. And about 3 months later, they called me up and they said, yeah, here's the license and everything. And go ahead, start testing it. And right now, it ain't working for crap. But
well, that's a little bit how Fusion's 3D printing slicer was at first. When it first came out, it was terrible. And then because you had to go in and actually edit the G code to get it to work.
Text editor, that was crazy.
But when you go over here, you got a choice between cut outside, cut inside, cut on.
Nice.
Or fill, if you're filling it and so on. It's got it's giving you laser cutters that you can set up for your laser, the size of the point and everything else.
So Howard, if you can get this thing to do additive, then this can be your tool, one tool to rule them all.
Yeah. I actually was going to buy the Aspire. I actually talked to Travis about it, but then my wife informed me that I spent my allowance for the year.
Hey, being I'm getting older than a lot of you guys, if I die, I just hope my wife doesn't sell the tools for what I told her I paid for them.
As Travis, go ahead.
I'd be disappointed.
As Travis will tell you, my wife is pretty flexible when it comes to buying toys. But when I told her what a Spire cost, she said, "Yeah, no."
It's software.
So that's why I got into the Fusion so much. So I'm going to be highly disappointed if, in fact, the additive license does require a fee. I don't believe it does, but I'm actually gonna call Autodesk tomorrow and ask them.
Hey, Mark, I'll send you the research I did on that, and that can get you started when you call them.
Beautiful.
How do you get out of this view?
Just up at the top.
It says stop sharing.
Stop sharing.
Yeah, the clues would be the words "stop sharing."
I do not see it.
Oh,
Very
it's supposed to
top
be at
of
the
the
top.
screen.
Pause share, new share, stop share.
We all share.
Stop share. There it is. Okay. I thought you might like that. That got me excited when I seen it the first time. And
It is cool.
It's, you know what? That company makes tremendous software. They just, oh my gosh, they're so proud of it. And they're going to charge for the laser part on top of the Aspire license.
yeah,
Holy mackerel.
Oh man.
I hope it's minimal, but who knows?
Minimal.
They'll let you upgrade for $500.
Yeah, right. Hey, Mark, in the chat, Lance says that he was interested in setting up a wireless Pi. I'm not sure if he was tongue-in-cheek because he goes on to talk about how onerous and very difficult it is to move it all the way across the room from one computer to another. But if that was a project that we wanted to, much like we did with the Tour lasers, if people were interested in the Octoprint, which is, I'm talking assuming everybody knows what it is. Octoprint takes a Prusa.
Yeah.
Pardon?
It's just the G-code sender, right?
Well, actually, you can control it remotely. It also controls the camera. I mean, there are a lot of things that you can do. You can schedule next prints. You can see progress. There's quite a lot that the Octoprint can do. And so I was only tossing it out there because of Lance's comment. But that could be another theme outside of this SIG if we wanted to pursue it. Just a thought.
Yeah, that'd be fun. I would like to do. I've already got the Raspberry Pi, and I printed out the enclosure for it and everything. I just, like I said, I got on this Fusion kick, as you know, and my saga of my liquid cooled spindle was quite humorous. I happened to buy it right during Chinese New Year, right before the COVID virus hit, and getting parts has been like running to the mailbox box for disappointment every day.
Mark was so sad, so sad. Hey Lance, why are you waving that SD card?
Yeah, I was joking about actually moving the SD card.
I figured.
It's totally doable, but it's just I literally have, I think I have 2 old Raspberry Pis like that are doing
Doesn't
nothing.
require much. I think 0 will work.
And I looked it up, and it's just like a rabbit hole that I've avoided because I feel like there's just someone who can just easily break it down. So that would be fantastic if anyone's done that already.
Just out of curiosity, by show of raising hands, how many people here actually have Prusas?
Oh, am I supposed to write? Does this count?
I think that counts, yeah. I'm going to do a different version. I'm going to do this one.
Here, I'll actually raise my hand for Travis so he doesn't.
Let's see if we can, I got to do that too here.
Yeah.
Well, there are not a lot of hands going up, so maybe there are not a lot of Prusas out there.
Howard?
No, I've got a
Travis?
QD 3DX Plus.
Okay. Luad Zima just ordered one, so he's not showing that he's got that. Anyhow, it was a thought. Maybe it's not a good thought.
Well, if there's a group of some group of people that is interested, that would be great.
The one thing about the project that you're talking about is you can get the Raspberry Pi for $40, print yourself an enclosure, and all the software is freeware, it's shareware, it's what do you call it, open source. So it's not like a big investment. So if anybody's interested, I'd be willing to put together some instructions and kind of go through a learning session with it.
Well, and you can also attach a camera to it, Mark. So it's just another extension.
Yeah, I'd be interested in that. But
And I was also curious about that part too, because there's probably a camera laying around that would work as
I use
Yeah.
Arlo's, and it's basically a hub that's in the house, and I've got cameras on my CNC on the laser and available for this, so I don't really have a need for that.
He just wants an alarm. If anybody gets close to his babies, he wants to know about it.
I do like the idea of the fire detector, though. I haven't done that, and I'm in the middle of building that lac enclosure. So I think I might add a fire detector to it. That's actually a smart idea.
I think Sam was saying he might be interested. Sam, were you one of the people who said was interested in the idea?
Yeah, I was gonna build that at some point.
Yeah.
The lac enclosure or the octopus eye?
That too. I actually have all the stuff printed, but need to find acrylic. Or
Print solid. $45 to the door, already cut, ready to go. Amazing. And they shipped it to me in about 4 days, even during the pandemic.
Okay. Because I did find half the pieces in the scrap in it. But not the big one.
Yeah, they print. It's exactly for that. It's called the Prusa lac enclosure kit, and it's $45, no tax, no shipping, shipped to your door.
Boy, that's cheap.
Yeah, I couldn't believe.
Yeah, I was gonna try to buy a whole sheet because I have a CNC, and then that was, the best they could do was $80 or something.
I'm sorry, Mark, what is the piece you're talking about? What is this?
It's it's 5 pieces.
Yeah.
The 2 sides, the back, and 2 pieces for the doors. And there's an actual kit that Prusa did, and this is the acrylic sheets for that kit.
But what are you enclosing? I'm sorry, I don't get it.
The Prusa.
The Prusa printer.
Oh, housing for the whole thing.
Yeah.
Okay,
You
sorry.
use the IKEA lac tables.
Oh, yeah. That's what you're doing, right?
Yeah.
Yeah, okay. All right.
The longest part is I ordered magnets for the doors from China like 2 months ago, and they're still not here.
I'm sure you could ask half the people on this call, they probably have spare magnets.
Yeah, now at this point, it's just like a mission, right?
Yeah. Hey, Tim, we really bombed when it came to the beer.
Oh, I have beer.
Oh, you've got one person came through.
Oh, no, I've been drinking. I already sent you a picture of it. I started drinking
Yes, you
at
did.
4:30.
It has your name on it.
Yeah.
What do you have
This
there,
is
Tim?
not the first one.
What do you have there, Tim? Oh, he's serious.
Nice.
You're muted.
I have Old Ezra Brooks Barrel Strength, the bourbon.
Oh, nice.
Is that what you needed to get through this because you knew you had a tough audience?
No, it was just the motivation to get through it.
Oh, I see. Okay.
Well played.
I have to say, I'm actually learning a lot, Tim. I play around with Fusion all the time, but I'm watching an entirely different way of approaching things is interesting. Like when you did the shelves, I would never have thought of doing it that way. I would have done an extrusion both directions with a cut on one side and an extrusion on the other. But that was really cool to watch. And then,
the thing is, like, you could like, if you had a hole through it before you did the shell, you would have a tube through. Like any geometry, you can have very complex geometry and then have a consistent shell wall thickness all around your part.
Yeah.
So that part actually didn't show the strength all that greatly of how complex a part you can take and then shell.
Oh yeah, I use the shell command. What I do is I use revolve and shell all the time to make parts because you can whip them out.
Yeah, I've used the revolve a lot too. You do the sectional and then you revolve it. And
then if you want to punch a hole through it, Sam, you just use the shell and go all the way through, and bam, you got yourself a tube.
Oh, I see. Yeah,
I got to go, guys. See you.
Thanks, Howard.
Okay.
Thank you, Tim.
You bet. Thanks, everybody.
Yeah, thanks a lot, Tim.
I really appreciate all the feedback. Last week, there were lots of questions, suggestions, all appreciated. And there's a suggestion for a challenge for next week. So it's in the forum. Maybe we'll bring that a little more forward in communications. And then next week, we'll do another just sort of a straightforward, closer to beginner lesson.
Thank you very much, Tim.
Thank you, Tim.
Thanks, Tim.
Go, Tim.
Very interesting.
Thank you.
How do we get that bourbon?
How's that?
How do we get some of that bourbon?
last July, I got the last 2 bottles in San Diego from
No kidding.
from what is it, Dick's Liquor in PB, and I was looking for 7 or 8 months, and my niece, or I guess my nephew-in-law, found some in Seattle. So they happened to come for a visit and brought some down from Seattle for me. So
Nice.
yeah, it's in short supply right now.
Keep those contacts.
It's a good one. It's a good one. Thanks, guys.
Thanks.
Good night.
Uh-oh. We